Okay. So some of you said you came here and could not download Streamlit. Is that correct? Or you've been able to resolve it now?
I was able to install it.
So everything is good now.
Yes. And the app is working too.
Awesome, awesome. Then I think you don't have to go over that. So you just have to maybe click on the Streamlit. It loads and just click on install and then you are good to go.
Install. Sure.
Yeah. Okay. If that's fine for you, means I believe everyone's also okay with that. But was it difficult to set up the other parts? Or it was quite straightforward?
Please, can you repeat that for me?
Was it difficult to set up the other parts? Or everything was quite straightforward?
No, it was you give out the step-by-step process. So I think I just followed it and then
So here's draw and color. No.
That's
So draw and
color.
color.
Oh,
Yes,
okay.
Dabadi, Jesse.
Okay, awesome. So today we are going to look at something we've seen before, right? And that is the funny way I sometimes teach. Before I teach something new, I've already mentioned it before, so it's no longer anything new. So we're going to look at some of these data structures and not surprisingly, we've seen some of them already, especially the list. Yesterday we even used the list, if you can remember. So the other cousins of list, we have dictionary, we have tuples, and we have sets. They also have a similar behavior. Okay, with lists. Maybe okay, let me create a new notebook. So you have a new notebook, then we start. So let's tuples, dictionaries, and then sets. So data structures we are saying are just containers, right? This is the way we created the list. I think we stored fruits inside that list, right? So we had a list of fruits, and we use a for loop to run through that list, right? So list, you can just see that one as a shopping bag, okay? And we can change the items. Tuples to behave in the same way, but tuples are so that you cannot change items. They are what we call immutable, right?
okay.
Dictionaries are also used to store pairs of what do you call it? Pairs of, let me say, key value pairs. The key can be one data type, the value can also be another data type. So it's just like the way we store our phone contacts, right? The name and then the number. So the name becomes the key, the number becomes the value. So when you search for the person's name, you can definitely get the number, right? So when you store things in pairs
Okay.
like that, then we so it's like you're using a dictionary. I believe you guys did JavaScript. JavaScript, they call dictionary objects. is the same thing, the same principle in JavaScript. And list too is the same as what they call arrays in JavaScript. So if you know arrays in JavaScript, then that's what Python calls lists. You also know objects in JavaScript, that's what Python calls dictionary. Okay, awesome. Then the sets. These behave like the Venn diagrams we all know about, right? You don't have duplicates in the set. If you have a set A, let's say a set of what do you have? Maybe colors, right? There is no way you see blue in one set. If blue will appear only once. Okay, awesome. So these are some of the things that we want to look at briefly today. So let's get started. So that man is ready. I think Manu is ready now. Okay, it's ready now. So we can call it data structures. Awesome. Good. And for lists, we've seen this before. We just use the square brackets to create it. And we also saw something about indexing of the list, right? So today I may just take the list again and then we'll just go a little further into lists, right? So let's take the lists. Let's start with that one. What's happening to the keyboard?
The GD na one say a G.
Okay. So Python list. So we can create a list and store it. Like,
I'm not seeing the screen.
you are allowed and store it in a variable. If you enjoy the video, kindly mute yourself. The other participants are not disturbed. Please, are you seeing my screen? Someone is complaining they are not seeing my screen. I think it's very visible. Okay. Okay. So let's create a list, right? Let's use yesterday's list, right? This is the list of fruits, and there's a square bracket, that's the notation, right? So we had mango. Let's just say mango. Then we have pear. We have orange. So this is a list, right? So we can find the type of this data stored inside the variable called fruits. And Python will tell us that what you have here is called a list. I think I didn't run that first, so let me run it. Each time you have name error, just know that you didn't run it, so that's all. Okay. So this is a Python list. Good. Now, with these data structures, okay, they usually come with something we call methods, right? Methods are already made functions which can be called on the data type or data structure. It can help you to do a couple of interesting things with the data structure. So we just look at it in general before we even continue what we are doing. So whenever you have a data type and you want to look at the inbuilt method or the secrets that is behind that data type, then the secrets may not be obvious at the glance, like at the first instance like this, but you can pull them out easily. And there's a way to do that in Python. If you're in trouble and you want someone to come to your assistance, what do? You call for what? What do you call for?
This meeting is being recorded.
Yeah. What do you call for? It's straightforward. You are in trouble. I'm not using the words. I want you to use the word. What do you call for? Let me see the chat. Oh, nobody is saying it. It's just one word. One word.
Call for help.
Call for help. Thank you, my brother. So we are going to call help. And then we'll just run this. List is a class. This is how we created this list. But see, all this part may not make any sense to you right now. So just so you get the part. P count, extend. These are what we call the methods of the data structure, right? So these are the things that tells you what you can do with this data structure and what you may not be able to do with it. Another way of getting this kind of help or assistance, whatever you are stuck and you want to do something with the data structure. Yes, I want to do something with the list, but I'm stuck. I don't know what to do. It's also use the dir. You can call the directory on it. So now let me just run this. And we still see the Danda methods, and we still see the ones that are clean, right? These ones. Which of these two do you think is the easiest way to get your desired methods? Using the help or using the dir? Which one looks quite cool? Okay, since nobody is talking, I'll keep on going. So let's experiment with some of these methods. I just have a reservation. I think the dir for me looks neater than the
dir.
Yeah. So let's try and play with some of these methods. Let's see how they work, right? Okay. So let's create a list. No, we already have a list. So our list is a list of fruits, right? Let me check whether our fruits are still working. I run the cell and good. Now, look at the method over here. The method here is called append. Let's go to the way help put it, and let's see whether help gives some more hints about it. Let me look at help, append. So append is giving a note down here. So that's the advantage of the help. It gives more details. So it says append object to the end of a list. Append just means add, right? Then that is interesting.
Yeah.
So let's see. We only have three things here. Let's try and add and see what that will give us. Okay. So we take fruits dot append. Now this is how to call the method. This is how to call these methods, right? You use a full stop. So this fruits over here, it's a list. We saw that the data type is what? List. If you forgot, let me do it again. So we have fruits. Sorry, put a type on the fruits. And we know that it's a list. So this list has a method called what? Append. So you forget about them. So the way me applying the append to the fruits, don't think too much about the fruits. Think of it being a list data type, having a method called what? Append. And how we call methods on data types is just this full stop thing. If you know the method name, just attach the method name to the data type that is either stored in a variable or wherever it is, and then call it. How do you call it? Just use the brackets. So now I want to, let me see, let's run this one and see the error we will get. So I run this cell and I have an error. The error messages, I said you should not be scared or afraid of our error messages if you want to learn programming. They actually guide you so that you know exactly what to do next, right? So what is the error saying? This is a type error. And it's saying that the list, do you see now when I was doing fruits that append, look at how Python is seeing my fruit. Python is saying that, see, this whole fruit that my guy has put here is just a list. So Python is saying that list, when you have a list and you call the append method, you must pass one argument to it, and we give it 0. What are arguments? Arguments are the things we put in the brackets. If that's the case, let me leave this error here, go down to the next line, and then give it an argument now. So fruit.append. What argument do you think I'll be giving to it? Because this is a list of what? Strings, right? These are string data types. They have quotations. So whatever is in the list, let me just try to add the same thing. So I'm going to add a string of what? Apple, fruits, and not fruits, sorry. Okay, now I've appended. Let's see whether the append worked. So I'm going to now print what is inside fruits. Let's print and see. Voila, Apple has been added. Is it cool? Makes sense? Yes, no, maybe. Okay. Now, from yesterday's lesson, we also saw that we can index lists, right? We can index lists. So list, we can list the items from 0 to the, and what, oh, sorry, how do I call it? I'm supposed to call fruits. So fruits 0 to 1. And I said in Python, it's just like JavaScript, what you learned. We start indexing things from what? 0 to 1, 2, 3. So what I call from 0 to 2, it means usually the last number is excluded, right? The last index is not included. So you give me mango and pear. That's what we have here. So in other sense, what it is doing is going to do this one up to the -1 index. That just means it will do 0 and 1, not 0 to 2. Makes sense? Yes, no, maybe. I think it is straightforward. If you've done JavaScript, I don't have to waste time on explaining indexing here. Okay, so we've seen one method all this while, it's just an append method. But from what we've seen, we have so many more methods, right? Append, clear, copy, extend, index, insert. Let me go for insert. And let's play with insert. So we have fruits and then dot insert. We call it this way. Of course, if I run this, we expect an error, right? Don't worry about error messages. They are guides. So now look at what it's saying. Fruits.insert. Insert expected 2 arguments and got 0. What could these 2 arguments probably be? Can we go back to help and go and find out? Let's go to help and go and see what this insert thing is really doing. Now, look at what is the short note here. So it's saying insert. Insert here it expects 2 things. From the error we got, look at the error carefully. I'm trying to teach you guys from a certain angle. I will have taught this in a different way, but I'm essentially going this route. So please follow me attentively. So instead, we just run it without any arguments. We know we'll definitely get an error. We are not afraid of errors. Errors give us guidance. Type error, it says it expects 2 arguments. But wait, guys, when we went up there to the help and we tried to read under insert, do you guys see 2 things here? Do you see 2 things or 3 things? Is it we should expect it expects 2 things, but how do you see? Do you see 2 or 3?
Things. 3. Self, index, and object.
Let me paste the note here. Okay, good. What did not work, we'll make it work. Let's copy it and bring it down. The way I'm teaching the Python, if you pay attention, you will never forget, you never get stuck in Python. But the same way I'm teaching it to, if you don't pay attention, you think today's meeting is the worst meeting of all our meetings. That's something that please pay attention for me. So what are we saying here? So the help method is giving us guidance. See, this how you can do Python even in an interview. And the one interviewing you will see that no, this guy understands the thing from the bottom up, right? You don't have to Google to look for anything. Everything is inside the Python itself. You can call all your help right in the Python code itself. Without going to, if you go to Google, the better will think that, oh, this guy doesn't know what he's doing. But once you are trying to find help for yourself, right from the Python code you are writing, then they will say that, hey, this guy is kind of different, right? He knows what he's doing. Okay. So let's read again. Insert, we know that it's expecting two things, index and an object. And I think it is going to insert an object. An object just means a new member of the list before a particular index you give. Now, to be more helpful, let me just print the code again. Print the fruits again. Then we can see all the positions of all the fruits. So look at it carefully. Now let's try to insert something after the first index, right? So we know that the first argument is expecting is what? What is it? It's an index before object. So index of, let's say, 1, and the object is, somebody wrote pineapple. Let me add that. Now let's see whether this will work. And then let's now check our fruits and see what's going on. Who can tell me what happened? What happened?
You have added pineapple to your work.
I've added it at what position?
After
At
the first one.
index 1.
Okay, who was at index 1? That's the question. Because they said that insert object before index. So who was at index 1 from here?
The
Who was at index 1?
index 1 was pay.
Good. So pair was at index 1. And we are inserting the object pineapple, right? Before pair. Do you see that? And it worked perfectly. It worked perfectly. Before what? Pair. Does it make sense? Does it make sense? Or I'm successfully confusing you? Do you want me to go over? I can go over. Let me check the chat. Okay. No, the yes. I'm seeing yes, but I don't know what the yes means. Yes, I should go over. Or more examples with the append or with the insert or with another method. We pick another one at random.
Like someone put it on the chat that I should go over.
Okay. So let's continue. You want to go over? Hold on, I'm coming. I'm teaching you guys today, but I've still not closed from work. Sorry for that. Okay, now let me go over that. So let me clean this. Or let's take one moment before we decide to go over, right? Maybe after that method, the revelation. Let's go back to the methods and see the one we can. Let's look at the pop. Pop looks interesting. Let me see. I see extend, I see. Let's just go for the pop. So how is the pop doing? Let's read under the help, okay? Help is very helpful for giving you notes on the methods and what they do. So pop, let's just copy it. I'm copying the whole of pop, the notes and the pop. Then we'll dissect it. So pop method of list. I paste it here. These are the notes I got of the help method. So what is it doing? It's expecting how many things? Self and the index, -1. Remove and return item at index. So the index here, -1 just means the last index, right? So with this fruits list, if I do an index of -1, I'll get apple. Let's try it and see. So we have fruits, and I just index it -1. What do I get? Apple, because apple is the last thing. So -1 just means last item. That's what we are trying to say. So when you do a pop, automatically, if you don't even, it's now this one, if you don't even provide any argument, automatically it will insert this for you. The last item, it will remove the last item from the list and then to give it to you. This is interesting. Look at it carefully. It will remove and return. Return means like giving it to you. So if it is removing and returning, then we can rather store the whatever is being returned with what? Inside the variable. Let me call this one store pop. I'll call this variable store pop. So that's what I do dot pop. Okay. Automatically. Automatically, if I do food of pop, Python inserts an index of -1 here for us. That means the last item. It will pop the last item, right? And then it will remove it from the list. And then I am trying to capture it. So whatever you are throwing away, you think you are throwing away your shirt, but somebody says, hey, I want your shirt. So that's what I'm doing with the variable here. Python is going to remove the last item, which we know is apple, and it's going to throw it away. But what is throwing away, I am storing it inside this variable called store pop. So let me run here, this one. And then let's check our fruits again, whether the last thing has really been popped. Do you see that apple is no longer there? That was the last thing. And let me check my store pop, the variable I call store pop, and let's see what is inside it. What is inside it? Is the apple. Who is getting lost? Sorry, I picked the country home. Hey, look at it carefully. Let's meditate on this, and then we'll continue. Any questions? Any questions for me? Okay, let me go to the chat and check what is happening there. Does it mean it will move and store what is being moved? It doesn't store. The storage occurs when you put a variable and then pop it into that variable, like what I've done here. So if I just did the pop, let's try it. You can try it, right? Right now over here, I'm doing fruits.pop. So this one will just move the last item and throw it away, but I am capturing it with this variable. So let's do another pop without the variable. Okay, and let's see what happens. So I do fruits.pop. So currently the last item is the orange, right? So this is the current state of the fruits list. So I run this cell here, and then I get orange, right? So it has popped it, and what has been popped is what is showing me here. Is it being stored anywhere? No, it's just showing that, see, I've just popped this one out of the list, orange. But has it stored it somewhere? No, because we did not capture it with any variable. So it has just been lost to the air. When we check fruits again, orange is gone, but we didn't store it anywhere. But in this case, I was trying to pop it and then capture it with the store pop. So that when we saw the new list, apple was gone. And when we went to where we stored our pop, apple was there. So you can decide to pop without storing. That's what I wanted to take note of. Okay. Let's take one last method. Now, I saw in the chat, someone was asking, can you add multiple mini strings? So, fortunately, there's another method for that. You don't use the append for that. So, let's look at the help. We are going back to the help. And let's look at the available methods. The one is called extend. Extend. Look at it carefully. Appending elements from the iterable. Okay. So let me copy this note here. So we can give another iterable. And I said yesterday that an iterable is like a list of things that you can start from the beginning to the end. A list itself is an iterable because you can have a list of items. You can start from the beginning to the end. A string is also an iterable, right? We saw it yesterday. We can start from the beginning and go to the end. Almost all the data structures we are talking about today are our iterables. We can go through them. Once you can go through them, means you can iterate. So let's look at the method called extend. Extend method of lists. This one is a little, not too technical, but it's a little technical, right? So please follow. Okay, let's apply it. To have fruits, this is the current condition of fruits. Right now, I want to feed this fruit with a number of fruits, right? I can't use append. Okay, let's try to use append. I don't know, maybe they've changed something in Python, but for what I know, so look at it carefully. I'll try and use append, and you must give it an iterable like a list, right? So let's see what's all the fruits. We have banana and what? Don't give me any food I can't spell. Yes.
Avocado.
Pineapple.
Okay, pineapple is already here.
Grapes.
Now let's
Okay.
we have fruit that are
Lime
pen.
green.
Pawpaw.
Okay, we'll come there. Let's just look at use the two for the meantime. So I run this cell and see something has happened. We were expecting an error, right? But it didn't give us an error. But let's really see whether it really worked. The way we thought or we are thinking to work. I do fruits, and let's look at what's inside it now. Now, guys, check what has happened. Mango, pineapple, pear. Then the two fruits we wanted to add, were they really added the way we wanted them to be added? No.
No.
But rather, the list itself is being seen as a single thing, and the whole thing has been added as one element. So that's why I said it's better we use the extend method. To extend, if you give it an iterable, it will go inside the iterable and pick the things from it one after the other and add it to your list. See, we don't need that last thing, so let's pop it out. So fruit the pop. And pop, what will it do? We throw that last thing away from us. So that we will now have our fruits again, right? Now we are going to copy this one. We can add a pawpaw to it, and we'll change it from the append method to the extend method. Let's add pawpaw to it. Some of you love pawpaw a lot, right? Pawpaw. Okay. Now let's check. We run this, and voila. What happened? Is it what we were expecting?
Yes.
Awesome. Are we good?
Yes, we are.
Okay, so that is, see, we can look at all the other methods, but time will not permit us. So, but I've shown you how to fish. You can now fish, right? You can take your time, look at the other methods. You can, if you don't understand it, you can go on Google, ChatGPT, blah, 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 and then you can get more notes or info. So that's all for the list, right? Okay. And we've seen append, insert. We didn't do the remove, but don't worry, I'll give you these notes. In fact, all the notes we have been using from the day one, all the web pages, I promise you, I'll give all of them to you. You can go and modify it and
Okay.
use it for your own purpose. Yeah. So don't worry
Okay. Thank
about the notes.
you. Thank you. In advance.
Now there's something here called list comprehension. Thank you, welcome. There's something called list comprehension. The way list is taking the whole day, I'm becoming angry at list. But please let me do this last one. I didn't want to teach list comprehension today, but or I should skip it.
No.
This is something I did in one of my interviews, and then it got me the job. So let me teach you list comprehension. Yes, baby, learn about the for loop, right? Today I'm going to put the for loop inside the list,
Yes.
and that's how it will get list comprehension. Today I'm really apologizing ahead of time. Oh, if I'm confusing you, please, I've already apologized. Today, forgive me. I knew that today would be a technical day, but just follow. You'll be fine. List comprehension. I'll try to make it as simple as possible. Now, if you have a list like this, let's start with, let's say, names, a list of names, right? We have Kofi.
We have Shadrach.
I'm going to add my name. Okay. Etc. Right? And then I want to take each of these names and add an S to it. Alright, I want to take each of these names and remove the last letter. So I can do for name, let me just add an S to it, right? For name in names, right? For name in names. It's going to be an interesting one. Let me create another empty list here called new names. New names. This is just an empty list, right? An empty list here. And I'm saying for name in names, I will take the name and what will I do to it? I will add S to it, right? Right. Let's try and see how this one works first. So let's print so I'll add S to it and I'll store it as new name. And now let's look at the result of this stage. So this is how we use print statements when we are programming. You don't wait to finish programming everything before you check what you've done. So at every stage, you can just add a print to see what's happening there. I want to see whether this code will work up to where we are right now. Let me go over it. So there's a list of names. There's an empty list called new names, right? Then over here, I'm using a for loop. A for loop, I told you yesterday, examples have to go through an iterable like this. A big container, small container, we can now go through each of the names one after the other. So now when we reach one particular name, so let's say Kofi will be here, the same Kofi will be here. And I'm adding the S to Kofi, right? And I'm storing it, what? Here as a new name. So let me just run this one and see what we get. Now this is what's happening here. We are getting Kofi. Let me rather do apostrophe S. That it will be like a possessive thing. In Python, this one funny thing that happens in Python. Even if you want to use a single quote, then the outer quote must be double quotes. If you want to use the double quote inside, then the outer quote must be single quotes. So let's try this. So we now have Kofi's, Ahmed's, Shadrach's, right? Okay. but they are not in a list. The reason why I created this new names empty list here is that whatever I get, I want to store it inside the new names. Okay. So now I've seen that the code is working up to this point, so I can now remove this print statement from there. And I can keep on coding. So I'll now say new names, this empty list, dot append. And I'm going to add the new name I created, right? One after the other to it. So that's what the for loop will do. The for loop will go through all of them, add this apostrophe S. Then when it's done, it will store them one after the other inside the empty list I created here. So this list, at the end of the for loop, I don't expect it to be empty again. So let me come outside the for loop and I'll print what? New names. And we'll see what happens. So let's run the cell. What do we get? We are getting Kofi's, Ahmed's, Shadrach's. So this is the new list. Does it make sense?
Yeah.
It makes sense, right? Or it's confusing?
It's confusing.
I getting the algorithm. The algorithm is simple. Take names one after the other, okay? Add an S and store it inside what? The new what? Or the empty list. That's all I'm doing here. So the best way to go to an iTribal is using the for loop.
A new
So the
name.
for loop is going to them, and I add what? An S to the old name to get a new name.
Okay.
Then I didn't see the append. We just saw the append, right? I
The
append
for
the new,
loop.
yeah, to the empty list. Then when I'm done, I just printed my final answer.
It's,
Okay, this
oh,
thing has been
okay.
quite long. Good. Don't worry, I'll go over it again. I'm coming. Now for list comparison, we can do the same thing. Open the square bracket, and I'll say for name
Okay.
in.
Okay, it makes sense. It makes sense now.
Does it make sense? Hello? Please, do you hear me? Am I audible? Like, I'm not getting feedback.
Yes, you're audible.
Yes, please.
Okay. Any questions? Let me relax here before I continue. I'll go and grab a cup of water. Any questions? Any question before I continue? Okay, if no question, let's continue. So now I'm going to do this with less comprehension. So I'm going to say name plus, let's say this version S, right? For name in names. I'm going to explain this, so don't be worried. So I'm saying for, now this is how we read list comprehension. Start reading it from after the for loop. So we read it from where? After the for loop. I mean, after the for statement, sorry. So we read it this way to the end, all the way to the end. So for every name inside the names, okay, then you come back and come and start. When it gets here, then you now come all the way here and come and start from here. So you get to the end of the for again. It's in two parts, part 1 and part 2. So let's read it together. For name in names, name plus apostrophe S. Does it make sense? So for every single name in names, add this thing to the name. And it's doing the same thing that this long thing here is doing. All of the long code, which was confusing you guys, is doing the same thing, which becomes neater and simpler.
The comprehension one, the new one that you did.
See, this is the last one I'm doing on the list. I'm not going to do any other thing apart from list. So this is what we call list comprehension. So all of this code here, all these long things here, I've done the same thing, but just
But,
one line. And
but it seems
look at
the first one is easy to read than the last one that you just did.
okay, let's vote. Those who think the first one is easier, type first. Those who think the last one is easier, type last. So compare all of this. No, the other code starts from somewhere around here. All of this here to just one line. For those who think first is easier, type first. Those who think last is easier, type last. Let me compare your votes. Don't worry, I'll give you another example. Don't worry. Manford is another example. So when you go to office, that's why you see different kind of Python programmers. What you using 1,000 lines to write? Someone will just do easy 5 lines. Okay. So as I said, this is how we read it. For name in names, always read from the 4. So for every name inside the names, just the name plus S. It's so simple. I feel like the first one is simple. Someone said, print the let's see. They don't believe it will work. Okay, let's run it and see. Did it work? Did it work or didn't work? Let me create a note here for you guys. So I'll call it one using list comprehension. Did it work? It worked, right? Okay, let's try something else. So, okay, let me try something that's more interesting. So let's take a list of names again, right? This time round, we are going to add Mr. to the people's names, right? Just Mr. Let's say a list of men's name, okay? So this is right, a list comprehension to add Mr. to the names below. So they give you the names. Right? And the names are what? Kofi, Mensa, and then what? I say Martin. And then Manford. Who else want me to add their name? You are you focusing? I'm only adding your name.
Prince.
Please add Ati.
You Ati. Okay. I like that name. And the last one will be Prince, right?
Yeah, sure.
You put you will pay me for typing too much. Okay. Now, who wants to give it a shot? Why you thought I'll be doing it for you? Who wants to give it a shot? Give me a list comprehension. Oh, this one, an example is right on top. So you should be able to do it easily. Who wants to
It's
try?
going to be names plus the quotation of Mr. for name in names.
It will be name plus
The quotation of Mr.
quotation, Mr. Okay.
Please, it's
For
double
name in
quotation.
names.
Double quotation to the Mr.
In names.
Sorry, it's going to be
Okay.
Mr. rather. Mr. first before the name. Mr. quotation of Mr. plus name.
Okay.
Please, no. It's the other way around.
Yes.
But the Mr. is supposed to be in double quotation mark.
Okay, so this one is giving us right. So let's try this way to work first. Okay, I run the cell,
Yeah.
and what do we have? Did it work?
Yes.
It kind of it worked, right? Maybe you just have to add some space here.
Mm,
So it worked. Let's
yes.
clap for him.
Pa for you.
So guys, is list comprehension difficult? Come and think through it again. Do you think it's difficult? Someone's also
Please,
try to
no.
write it with a follow. It is to me, it's easier. In fact, I love list comprehension so much because I'm a lazy guy. I don't like typing too much, as I said. When I see I can use list comprehension, forget about it. I'll use it. Okay. So do you see how Python can quickly move from too easy to let's go deep? So that's why you have to be learning constantly, right? And I think I pointed out some resources you can use to learn Python. Did I mention W3 schools? W3 school. This one. Almost every language you can come here and learn. Java, JavaScript, C++. See, they have even listed them at the top here. So that's Python for you. And if you look at it carefully, what do you have? You have almost everything here. Data types, variables, booleans, lists, tuples. So what we are doing today is lists. But can come and continue here, tuples, sets, dictionaries, if else, everything is here. So I don't want you to stop learning because today is our last but one meeting, but this will be the end of our learning. They just intro to get you started, to get you excited about what you can do, right? And then you inject the app development side into it, and then trust me, you have fun, and your kids will also have fun. Because whatever you are learning right now, you can teach them this theory. The later on, you think of how do we build an app with this? An app that makes use of list comprehension, so an app that makes use of for loops and lists and what have you. Then give them that project work and they go and build the app and bring the app. So all the time, your assignments or your projects will be apps that they are building with either Gradio or Streamlit. And you come to the class and just teach them some things about the theory or the theoretical aspect of it. Then they go home and they're having fun building apps, right? And the ones I'll give them some tests. I'll give you guys a test to write for me. I know teachers are not afraid of testing. This will be our objective test, Python objective test. Just 3 of them. Just not afraid of tests. Okay. Any questions? Any questions?
Please, my question is the double quotation and the single quotation. Will they all work if you try to use any of them?
Yes, it will work. So strings can be created using single or double. The challenge is what I spoke about. If you want to get like this apostrophe S, this quote S, right? A single one. Then make sure that when you are creating a string, you don't create the outside one with single quotes. If you want a single quote to be part of your string, like characters, then don't use single quotes either. You must use double quotes. If you also need double quotes to be part of what you're writing inside, then use single quotes outside. That's the only condition there. I hope it makes sense. Because
Sure.
I needed a single quote inside, I had to use a double quote on the outside to define the string. Okay. Now, there's something that I want you guys to look at. See, strings, usually the way I teach Python is that I teach a lot of strings and string methods, right? So today we've seen the data structures. But of the time, I don't want to go far. But let's say we are now left with what? Dictionaries, right? Dictionaries, tuples, and then let's say sets. And with all of these ones, we can call the help function on them. So help dictionary, right? And if that's a dict, that's a shorthand for dictionary, right? And then we can see the methods of a dictionary, right? You can also call the dir on dict. The same way I've explained list, you have the same thing for dictionary to copy, font, get items, blah, blah, blah. Then you can do the same thing to what? Tuples. Sorry. Guys, please hold on a minute. Okay, let's continue, team. So for tuple, so like this is the example of a tuple, right? You can call the directory method on it. So almost all the methods. Now, I do not do this for strings. Usually, as I said, usually when I'm starting to teach this, the number one thing I start with is strings. Because more often than not, if you understand all the string methods, see that we have so many methods here in a string. Understanding the other methods of the other data structures will be quite easy, right? Will be quite easy for you to get. Okay. Any questions? Okay. Let's go back here. We're done with the list. Now, tuple, let me just show for the other ones, I may not necessarily go into the methods, okay? Within 5 to 10 minutes, I'll finish the other ones with just highlighting some of the popular methods within them without writing in any code. But I've used list as a scapegoat, right? To explain how to get the methods, how to use them, how to even search for what they mean. So the rest, I'll just have to walk you through this notes, and then you can try the course when I share these notes with you. So we have tuples here. So tuple is an ordered, immutable, that is unchangeable collection. Okay. Once created, you cannot add, remove, or modify items. And let's see from here. When I did the directory on tuple, look at the popular methods. There's only count and what index. There's nothing like append and those kind of stuff with it, right? don't confuse it with this add. This add means if you have two tuples, you want to join them, right? But that doesn't mean you are extending the elements of the tuple. So tuples, you can't add new elements to them. That's what we are going to say. Okay, so you have coordinates like this, and sometimes it's great to have data type that you are not able to modify. It makes your code more robust, right? So in some cases, we may not want to modify the code. So you have coordinates, and the syntax for tuple is round brackets separated by what? Commas, comma separated. It can have 2 elements, can have 3 elements, like as in this case, or more than that, right? Any number above 2 elements. And sometimes in Python, when you don't even place the round brackets around the tuple, Python still sees it to be a tuple. Some way, somehow, Python still sees it to be a tuple. So sometimes you see me doing things like, or see some people doing things like, let me see what popular, let me see, name, country, what's it called to. So I would unpack this for us and say, okay, we have name here, and then we can have the country. So sometimes they call it one unpacking the tuple, right? So you can get elements of a tuple, and I'm unpacking the tuple with this also a tuple here, but just that I didn't put brackets around it. That's what I'm referring to. Okay, now we move to dictionaries, right? And sometimes, okay, I think that's what I'm explaining here. So you can have a student record coding so many things like this, like what we have here, name, and maybe you can say this on the age, right? Maybe the name, the age, the level, and then the grade. So you can have all of these things inside this single thing called student record. But because it's a tuple, we can unpack the tuple with what? Single variables. And they will begin to fall inside the pack. So the Kwame will come and fall inside this one. Now take note, Python doesn't really know name, age, all of these things are just variables, right? Variables are just mean container. So don't think because we have named this one name, that is why the name is going inside it. No, it's more of order, the order in which we have placed the variables here. If you bring the age variable here and bring the name variable here, the name is the first thing. It will be stored in the age. I don't know that making sense. So let me show you what I mean. I copy this, take it here. I paste it here. Go back, I copy this line. And then I paste it right below. So let's say I'm changing the name. I copy the name and put it here. And I make this one age. As I mentioned, all of these records are being stored in a single variable called student record. But the name is the first record. 17 is the second record. And I'm saying that if you miss this variable, the way we name the variables are just for our benefit as human beings, that we just understand it. But if you put the wrong variable at the wrong place, age will now end up storing what? The name. Let's check whether it works. So I do age, and then what do I have? I have Kwame. So as I said, Python doesn't know these English names. All you know that these things are just containers. So if you don't place them well in the right order, you end up storing the wrong thing at the wrong place where you did not intend it to be stored. That's just something about unpacking I wanted to take note of. So these things are just helpful for us as human beings to name them meaningfully, but to Python, it's just seeing containers, so that's all. Okay, dictionaries, how do they also behave? Now, most of the applications we write that have to communicate to the internet or move data over or across the internet, we'll be using something called JSON, and JSON and dictionaries are basically very close, right? So what do we do? So all of these data structures, if you've realized, whenever we create them, we create a tuple, we can store the whole tuple inside a single variable. So variables can hold any type of data, as I said, strings, integers, a whole list, a whole tuple, a whole dictionary. So these are some of the principles in Python you must get familiar with, right? So how do we define dictionaries then? Dictionaries are defined with curly brackets. And as I mentioned, they have data stored in pairs, which we call the key and the value, right? Let's copy this thing over to our notebook. So let's create a text cell here. I promise not to code, so I'm not coding anything. I'm just going to between. Okay, so this is the dictionary. And we stored it what? Inside the variable called student, right? So over here we can do type of what? Student. And then we see that it's a dictionary. That means all the dictionary methods can be applied, right? I can do student. Then we have what? Name, right? So these are how dictionaries are very efficient. So once you have the key, automatically the value can be pulled out. The first parts are what we call the key or the keys, just like the JavaScript objects, right? And the second part are what we call the value. So we use the key to index the value. Okay. So we can just look at all the student dot keys. It lists all the keys for us. So you have a name key, age key, class key, subject key. When you know all the keys, then you can start using them to index the dictionary, right? So we have a key called class. Let's try that key. And then we can see it, right? So if you need this kind of data structure whereby you have keys and value pairs, then you can go for dictionaries. In the same way, if you can get all the keys, obviously you should be able to get all the values too, right? So this is what gives us all the values. Okay. And we can write a for loop to go through this dictionary, right? So we can say for item in student, print item, right? Now look at what's happening here. So for item in student, print item. Okay, then we can do for student.items. Now, what's the difference? The difference is that when we are having a dictionary, okay, like student, and you do items, items gives both keys and values. We give the two pairs. Let me go by that quickly. When you do student.keys, you only have the keys. Student.values, you have the values. But when you do student.items, then you are getting the keys and the values as tuples, right? You see that these are tuples. Round brackets are tuples, right? Separated with comments. Now, I'm going to try to use the for loop to play with the tuples I'm getting. So for item in student.items, so student.items gives me all of these tuples. So it's giving me the tuples as a list. Look at it carefully. So this is a list of tuples. So in my mind, I am going to go through this list of tuples with the for loop. So the for loop will now pick each tuple out of the list, one after the other, and then print the tuple for me. So that's what's happening here. If you are confused, I hope it's clear now. So for item in student.items, print item. Then we are getting what? Each of them, each of the tuples. Make sense? Yes, no, maybe. I promise you today will be technical, a little technical. I hope I'm not disappointing you. I'm giving you technical stuff. So dictionaries, that's how basically dictionaries behave. It stores things in key value pairs for us. We are able to index the dictionary using the name of the keys if we do. If we don't, just do student.keys, all the keys will come. They can start using a key to index the dictionary. If you want to see all the values, student the values, all the values will come. What about if you want to see them in pairs? So you do student.items. This is also a special method. Now, where am I getting all of these methods from? I hope nobody's asking that question because you know where I'm getting them from. You do dir, dict, and then you see those methods. Where are they? Just scroll down. You see items here which I've used. You see keys here which I've used. You see values here which I've used. The other ones I've not used, right? The clear, the get, the keys, you know what I mean, the pop. We've seen pop before, right? And we are seeing it again. If you want more notes, I'll just do what? Help on the dict. And then you give you more notes about the pop and what have you. Let's check the pop. So that's the same pop we know or a different pop. Look at it. Remove and return a key value pair at a tuple, right? Pairs are returned in last in, first out order. Let's try the pop and see what happens. This is the note and the pop. And I'll just do student pop. And it said it's expecting at least one element and got what? 0. So from the notes, what do you see here? Who can help me with what the error message is saying? Anyone to volunteer?
You did not give it the value, the key and value that you want to copy out of the dictionary.
Okay, how many items are we expecting to do? How many arguments are we expecting? How many items?
One pair, key and value.
Okay. So, the key and value. This is what is going to remove and return, right? But
yeah,
what is expecting just one thing. It's not two things, right?
So it's expecting one thing, yes.
Yeah. So let's try using the key, right? So let's say name. This is one of the keys, right? We have popped using the key. So what this expresses is just a key. Okay, so when you pop the key, now let's try and see the student dictionary, what is inside it. Now the key pair has been moved. Even though we use the key to do the pop, it has removed that particular key and its corresponding pair value. Right now we don't have any name inside the dictionary again. All the other keys and values are there. But the name, key, and the value, they are gone. So it's quite similar to the list pop. Okay. So we've seen the last three data structures. We've seen tuple, we've seen dictionaries. And then there's the last one, the sets. Now this set, it behaves like the way, as I said, the way we learn the Venn diagram. We have the Ghanaian languages, Shiga, Ewe, Dagbani, and their scores. Right? Now, how do you define a set? The set is very close to the dictionary. It also uses curly brackets. Now, if you can realize from here, there's something going on here. It's not key value pairs, but the items here are very, very unique. Okay. So we can have intersection of sets, we can have union of sets, and so on. So let's look at that here. So we have science club, math club, right? So this is the union of the set. All students in the science or math club, we have union of all of these names. And that's the symbol for the all union. Then the intersection, both clubs, both science and math, you just use the and symbol, and it finds the intersection of these two sets for you. And you have one club only. even the only, this is what you use, right? The carrot, right? The science club, carrot, the math club, and then it gives you those who are only in one club. So the same way we learn Venn diagrams and set operations in math, the set data structure enables us to perform these kind of operations. And the syntax looks like dictionaries, but it's not key value pairs. It's just items in the curly brackets. So basically that's that. Team, I would like to drop here, end here. Any questions for me? So as I promised, you have the notes, and you also have this notebook. Let me give you this notebook quickly. And then I will post the notes by end of all that we have done. I mean, by the end of our last lesson, I'll give you the link to where you can get all these notes. That is the web pages I created. It's created for you purposely, okay? So I've shared it here with you. Let me share it also on WhatsApp with you. Awesome. Any questions for me? That's been a long ride, right? Yes or no? Let me know in the chat. Today has been a long